Hello children, how are you all? Welcome to digital classes. Dear children, in lower classes you studied about matter and the properties of matter. Also you studied that Dalton atomic model. Children, Dalton proved scientifically that matter is made up of atoms, that is the last and ultimate smallest particle. Dalton was successfully explained about law of conservation of mass, law of constant proportions and law of multiple proportions. Dalton could not explain about why electricity is generated when we rub a glass rod or when we rub on the surface of a ebonite rod. To explain about the generation of electricity, various discharge tube experiments have been done by different scientists like William Crookes, Maxwell, J.J. Thomson, and they discovered that there are some fundamental particles inside the atom. By doing various discharge tube experiments, the scientists have been discovered that there are some fundamental particle inside the atom like electron, proton and neutron. Children, in today's class we are going to learn about the arrangement of this fundamental particle inside the atom. The arrangement of fundamental particle inside the atom is called atomic model. Various atomic models were proposed by the various scientists. Among all, the first one is Thomson-Plum-Pudding model. According to Thomson-Plum-Pudding model, atom is spherical in shape and the positive charge is uniformly distributed and electrons are embedded into it. Thomson said that he compared that atom with watermelon and how in a watermelon red color pulp is distributed and seeds are embedded inside the pulp. In the same way, inside the atom also electrons are embedded in the positive charge. So, Thomson atomic model is also said to be as watermelon atomic model, but Thomson atomic model could not explain about all the properties of atoms. That is why Thomson atomic model was discarded. Then another scientist came forward to explain about the atomic model. Then the second one is Ernest Rutherford atomic model. Rutherford did alpha-ray scattering experiment and he discovered that he did that alpha-ray scattering experiment. In his experiment he used alpha particles to fall on a thin gold foil and most of the alpha particles are passed straight in through the gold foil and very few alpha particles are deflected with certain angles, and out of 20,000 alpha particle one is bounced back. Based on these observations, Rutherford concluded that most of the mass of the atom is located at the center of atom, and he said that the center has a nucleus. In this nucleus both protons and neutrons are present and most of the atom is empty and electrons are revolving around the nucleus. How in solar system planets are revolving around the sun. So, in the same way he compared that atom with a solar system. See children, here atom is very minute, even we can't see with our naked eye, and he compared that atom with solar system. That is why Rutherford atomic model is said to be as planetary atomic model. But Rutherford could not explain all the properties of atom. Mainly he failed to explain about the stability of atom and line spectrum of atom. Why? Because when electron is revolving around the nucleus, as it is a negatively charged particle, when it is revolving continuously around the nucleus, it will emit the radiation and it should fall on the nucleus. If it is fall on the nucleus, atom must be collapse. But we have studied that Dalton said that according to Dalton atom is more stable, we can't break the atom, we can't destroy the atom. That is why Rutherford could not explain about the stability of atom. To overcome the demerits of Rutherford, another scientist came forward to explain the properties of atom by using electromagnetic radiations which have dual behavior, that is wave nature and particle nature, and he believed that atomic spectra can only be explained by quantized energy level. Children, before going to the Niels Bohr atomic model, let us learn about a spectrum. Children, what is spectrum? Spectrum is nothing but a collection of colors. Spectrum is nothing but collection of group of wavelengths. Children, you might have seen the rainbow during the rainy seasons. 7 colors you can find there: violet, indigo, blue, green, yellow, orange and red. Simply we will say them as 𝗹𝗁𝗃. In rainbow we will find the 7 colors, and that 7 colors are visible colors, and it is said to be as the visible spectrum. Rainbow is the visible spectrum. Children, visible light is also an electromagnetic wave, and the speed of that light is 3 into 10 power 8 meters per second. In other words, 3 lakhs kilometers per second. Children, do you know what is wave? We are very familiar with that waves. When we throw a stone into the water, we will see the transmitting of waves. When we hit a drum, we can find the waves producing and how the sound is propagating from one place to another place. In the same way, electromagnetic waves are also produced when an electric charge is vibrates. A vibrating electric charge creates a change in the electric field. The change in the electric field creates a change in magnetic field. Here both electric field and magnetic fields are perpendicular to each other. See here, the electric field and magnetic field being perpendicular to each other and at right angles to the direction of propagation of the waves. Electromagnetic waves travels through vacuum and behaves in the same way like other waves. A wave can be characterized by wavelength, frequency and energy. Children, here you focus electromagnetic waves also like other waves, how other waves are propagating and how other waves are behaving. The difference is, for other waves they need medium for the propagation, and electromagnetic waves does not require any medium, and in absence of medium also they can propagate. And here, like other waves, these waves also can be characterized by wavelength and frequency and energy. And what is wavelength? Wavelength is the distance from one peak to next, or the distance between the two adjacent identical points of a wave. In the diagram you can see there, two peaks are connected and it is denoted with what? Lambda. The symbol lambda is used to represent the wavelength, and the other one is frequency. The number of wave peaks that pass by a given point per unit time is known as the frequency. Children, you can find here, one is higher frequency and another is lower frequency. If the wavelength is very short, then frequency will be more. If the wavelength is longer, then the frequency will be less. So here lambda means wavelength and frequency both are inversely proportional to each other, and these two are related to the speed of light. Here speed of light is indicated with the c is equal to lambda into v. And another one is energy. The energy of a certain frequency can be represented by the equation E is equal to h mu. Here E stands energy, h stands Planck's constant, that value is equal to 6.626 into 10 power minus 34 joules, and mu indicate the frequency of radiation. Electromagnetic energy, that is nothing but light, it can have only certain discrete energy values which is given by the equation E is equal to n h mu. Here n is equal to 1, 2, 3, and the next topic is electromagnetic spectrum. Children, do you know what is electromagnetic spectrum? The electromagnetic spectrum consists of a continuous range of wavelengths of all kind of electromagnetic rays. In the diagram you can find cosmic rays, gamma rays, X-rays, ultraviolet rays and visible light, infrared waves and microwaves, radar waves and radio waves and broadcasting waves. So, different type of waves you can find in the electromagnetic spectrum. Simply it is a collection of all kind of electromagnetic radiations. You can find here electromagnetic spectrum, you can find very clearly gamma rays, X rays, ultraviolet rays and infrared rays and radio waves. Here visible light is ranging from 400 nanometers to 800 plus nanometer. The range of that range of wavelength indicate the visible light, and here you can find the all the different 7 colors. See children, here you can find the visible spectrum. The range of wavelengths covering the red color to violet color is visible spectrum, because these colors only we can see with our eyes, and other electromagnetic radiation we cannot find with our eyes. Dear children, have you went to blacksmith who molds the metal articles in the required shapes? There he will heat the iron objects to the high temperature, and there we can find the different type of radiations which were emitted by the hot body. Now let us see a video where we can find that different colors. Children, here we are heating iron object to the high temperature. The same scenario you can see at blacksmith. Here you observe it, we can find 2 different colors, one is blue and also red. As it cools down, the colors disappears. Again if you heat, you will get the another color. You can see here red, clear red color, and also beside that red color you can find the blue color also. See here, when it is heated to too high temperature, you can find different colors, white, yellow, orange and also red color. If you heat it to more temperature, completely it will turn into white color, and you can find different type of colors, but due to emission of one particular frequency, the other colors cannot be seen. So mainly here you need to remember, whenever an iron object is heated to high temperature, the 4 colors you can notice, that is white, yellow, orange, red and also blue color. Children, let us do another activity to identify the different colored flames. For doing this activity, we need a different type of salts and a Bunsen burner, where we will get the non-luminous flame. Let us do the activity. For doing this activity, we need to take copper chloride, which is mixed with the concentrated hydrochloric acid, and take that copper chloride salt which is mixed in the hydrochloric acid, and keep it in front of a non-luminous flame. Children, you can notice here a green color flame. Observe it, copper chloride is giving that green color, and now take strontium chloride salt which is mixed with hydrochloric acid, and in the same way keep it in front of non-luminous flame. Children, you can notice that a crimson red color flame, you can find it. Now let us do with sodium chloride salt, similar experiment. Here you can notice that golden yellow color flame. Dear children, copper chloride produces a green color flame, strontium chloride produces a crimson red color flame, sodium vapors produces yellow light in street lamps. Children, not only these 3 salts, various kind of colors you can find during the firecrackers. When we crack the fire, you can get that different type of flames. Each element emits its own characteristic color. These colors correspond to certain discrete wavelengths of light and are called line spectra. Children, you see the spectra, Rutherford could not explain about the line spectra, because each and every element gives a separate line spectra. So using this concept of line spectra, Bohr could able to explain the demerits of Rutherford atomic model. Now let us go for the Bohr's atomic model. What is Bohr's atomic model? According to Bohr, atom has nucleus in the center and electrons are revolving in the fixed orbits around the nucleus. These orbits have fixed radius and energy. These are represented in the form of concentric rings around the nucleus. These are labeled as K, L, M, N, O or 1, 2, 3, 4, 5 shells, or these are also called as orbits. See children, here in this diagram you can find a different type of shells, K, L, M, N shells. First shell is K shell, second shell L shell, third shell M shell, and fourth one is N shell, and the total positive charge is located at the center of the atom, that is nothing but nucleus. While electron is moving in fixed orbit, there is no change in the energy, hence these orbits are called stationary orbits. These energies of an electron in an atom can have only certain values like E1, E2, E3 and so on, that is the energy is quantized. The lowest energy state of the electron is known as ground state. When electron gains energy, the electron moves to a higher energy level is known as excited state. The electron loses the energy and comes back to its ground state. It means at excited state electrons are very unstable, they can't stay back for long time, immediately they emits energy and comes back to the original state, that is nothing but ground state. See in this diagram you can find that it was clearly indicated, plus symbol where it is indicated, that is nothing but nucleus, and the inner shell where electron is indicated with E minus symbol, that is ground state, and while by taking the energy it will get excite, and that state is nothing but what? Excited state. Electrons are getting absorbing energy and they are getting excited to excited states, and at that excited state they are unstable, that is why they will release the energy and they comes back to the ground state. The energy emitted by the electron is seen in the form of electromagnetic energy, and when the wavelength is in the visible region, it is visible as an emission line, that is why we will get the line spectra in visible region. In this diagram you can see very clearly, while electron is going back from excited state to ground state, it is emitting the energy in the form of a photon. A photon is emitted with energy E is equal to h mu. The excited electrons emit energy to return to the ground states from the excited state. The emission spectrum is formed by the frequencies of these emitted light, and absorption spectrum is formed with the dark bands when energy is absorbed by the electrons in the ground state to reach higher energy states. Children, here you can observe visible spectrum can be divided into two types, that is emission spectrum and also absorption spectrum. Here in this you can find emission spectra and absorption spectra. In case of emission spectra, it comprises colored lines in the spectrum on a dark background, you observe it. So when the emitted radiations are collected on a photographic plate, you find this kind of emission spectrum. In this emission spectrum, the background will be in the black color and the visible colored lines can be noticed in emission spectra. Children, when do you get the absorption spectra? When electron get excites from ground state to excited state by absorbing certain wavelengths, and it comprise dark lines or gaps in the spectrum. Here you can notice absorption spectrum with bright background and dark color lines. These dark color lines are nothing but missing lines. It means for which lines are belongs to the particular wavelengths, that wavelength radiation was absorbed by the electron for the excitation. Children, hope it is very clear about emission spectrum and absorption spectrum. I will repeat once again. Emission spectrum is formed due to the emission of radiation when electron comes back from excited state to ground state, and absorption spectrum is formed due to the electron transition by the absorption of radiation for excitation from ground state to excited state. Children, what are the limitations of Bohr's atomic model? It is a successful model as far as line spectra of hydrogen atom is concerned, but Bohr model failed to account for the splitting of line spectra, that is Zeeman effect and Stark effect. Children, what is Zeeman effect and what is Stark effect? First, let us learn about the Zeeman effect. Zeeman effect is the splitting of line spectra of hydrogen atom into finer lines in presence of magnetic field is known as Zeeman effect. It means, in simple words, you can say that the spectral line, the splitting of spectral lines in presence of magnetic field is nothing but a Zeeman effect. I repeat once again, the splitting of spectral lines in presence of magnetic field is Zeeman effect. Here you can notice, children, you find this, in absence of magnetic field it was a single line, but in presence of magnetic field you can find it has splitted into 3 lines. So, this splitting is nothing but what? Zeeman effect. This Zeeman effect takes place in presence of magnetic field, and other one is Stark effect. Children, what is a Stark effect? The splitting of line spectra of hydrogen atom into finer lines in presence of electric field is known as Stark effect. Children, in simply you can say that the splitting of spectral lines in presence of electric field is known as Stark effect. Here you can see this. In absence of electric field, you can find one red color line, one green line and one blue line, but in presence of electric field each line is splitted into more number of lines. This splitting is nothing but what? Stark effect. Now, let us learn about Bohr-Sommerfeld atomic model. Actually, to overcome the demerits of a Bohr atomic model, Sommerfeld has given some corrections, and what are that corrections and what Sommerfeld atomic model is saying. Now, let us see it. Sommerfeld corrected Bohr atomic model by adding elliptical orbit. He added elliptical orbit to the Bohr atomic model, and he said that the first orbit of Bohr is a circular. One elliptical orbit is added to the Bohr's second orbit, and 2 elliptical orbits are added to the Bohr's third orbit, and etc. Children, you can see in this diagram, the first orbit is a circular, and in the second one circle, and the second one is nothing but elliptical. In third orbit there are 3 subshells, one is circular and remaining 2 are elliptical, and in the fourth there are 4 subshells and one is circular and remaining all are elliptical orbits. See here, the nucleus of the atom, according to Sommerfeld, the nucleus of the atom is one of the principal foci of these elliptical orbits. Sommerfeld was successful in accounting the fine structure of hydrogen atomic spectra, but does not provide a satisfactory picture of structure of the atom in general. It means he could not apply the same concept for other atoms. This model failed to account for the atomic spectra of atoms of more than one electron. This model failed. Why is the electron in an atom restricted to revolve around the nucleus at certain fixed distances? Children, both Bohr atomic model and Sommerfeld atomic model and previous what we have studied Rutherford model and J.J. Thomson atomic model, no single model could not explain completely about the properties of atom. All these are classical approaches. Dear children, if the electron revolves around the nucleus in definite path, the exact position of the electron at various times will be known. Electrons are invisible to naked eye. Then how do you find the position and velocity of an electron? Children, then how can we find the position of electron in an atom? Is it possible? No. Why? Because simultaneously the position and velocity of electron cannot be measured accurately. Now it is clear that electrons do not follow a definite path in an atom, because to see an electron, a light radiation should fall on that particle and the reflected radiation should reach our eyes, then only we can see any object. In the similar way, to see an electron, a particular energetic radiation should fall on the electron and that should be reflected and reach to our eyes, then only it is possible to see that but practically when a radiation fall on electron, the position of electron and the velocity of electron will be changed. That is why it is not possible to find exact position and velocity of electron simultaneously. This means that an atom does not have a definite boundary. So, it is not possible to pinpoint an electron in an atom. To understand the properties of electrons in an atom, a quantum mechanical model of atom was developed by Erwin Schrödinger. He introduced a new concept. What is the new concept and how he explained the structure of atom, we will see in the next class. Let us revise what we have studied in today's class. In today's class, we have studied the Thomson-Flumfording model, Rutherford model, also studied about electromagnetic waves and its properties. We studied about Bohr atomic model, and according to Bohr model of atom, electrons are present in the circularly stationary states, and according to Bohr-Sommerfeld model of an atom, electrons are present in elliptical stationary states. And also we studied about electron in an atom can gain energy by absorbing a particular frequency of light and can lose energy by emitting a particular frequency of light. Atomic line spectra arise because of absorption or emission of certain frequencies of light energy. It means the spectrum is formed for any element, the spectrum is formed due to the emission of light or due to the absorption of light. Children, try to improve your learning by answering these following questions. Rainbow is an example for continuous spectrum. Explain it. What is absorption spectrum? What is emission spectrum? How many elliptical orbits are there in the third Bohr's orbit? Collect the information regarding wavelengths and corresponding frequencies of three primary colors, that is red, blue and green. The wavelength of a radio wave is 1 meter. Find its frequency. Please download worksheets from SCERT for better learning, good practice. Thank you children. We will meet in the next session.
ఆహారం పాడవకుండా ఉంచడం